Welcome to section 5.5, solving quadratic equations using the zero factor property. Alright, so before we start, I have a question. If you multiply two numbers together and the answer to that is 0, do you know what one of the numbers is? Let's think about that. So you have a number and you're timesing it to another number, let's just say k, and the answer is 0. Do we know what one of the numbers must be? Well, in order to get 0, we know that either n must equal 0 or k must equal 0, right? In order to get an answer of 0, one of the two numbers must equal 0. And this is the basis that we create, or we look at, the zero factor property. Because in the zero factor property, we have the following. If a times b equals 0, then either a equals 0 or b equals 0. Basically, what I explained above. So how does this help us? Well, when we're solving something that's quadratic, so solving quadratic, what does quadratic mean, by the way? Quadratic is the formula, an equation, ax squared plus bx plus c equals 0. So it's not linear, okay? How do I know it's not linear? Well, I have a square on my variable, okay? So these are my variables, and one of them has a square. That's how I know I'm working with quadratic. So note, we don't use this property if we're solving linear equations. We use this property for quadratic. Okay, so very important. So we use this for solving quadratic. Now, if we happen to have our quadratic factored, we can use this property. Let's take a look at example 1. Solve, and we have x plus 3 times x minus 2 equal to 0. This is equal to 0. So I know by the zero factor property that either x plus 3 equals 0 or x minus 2 equals 0. So let's go ahead and set them equal to 0. And I'm just going to use this little line down the middle to separate my two equations. So once again, we're setting this equal to 0, just like we would here. Okay, we're setting each of the factors to 0. And then let's solve. So subtract 3 from both sides. And we get one possible solution is x equals negative 3. Now the other one, go ahead and solve for x. We find out that x equals 2. So I actually end up having two solutions that make my equation equal to 0. Negative 3 and 2. So this one was easier because it was already factored for us, but that doesn't always happen. Let's take a look at example 2. Well, first off, what kind of an equation is this? Because I need to know what kind it is, because that tells me what method to use. And at the moment, we know of linear equations and we know of quadratics. Do you know which one this is? Well, it's quadratic, and how do I know that? Because I have the little square on my variables. Okay, so this is quadratic, and the method that I'm going to use to solve this is the zero factor property. Mainly because it's the section we're working on. But how do I know what to do? Well, the first thing is set it equal to 0. And at the moment, it is not equal to 0. How do I know that? Well, there's a 4 on one side, so let's go ahead and bring the 4 to the other side. Minus 4 from both sides, and rewrite this. We have 3x squared minus x minus 4 equals 0. Okay, so it is set to 0. First part is done. What's the next thing I need to do? Well, remember, it's in the name of the property. First we set it to 0, and then we factor it, hence the zero factor property. So let's go ahead and factor this. Now let's see, so we have the factors. For 3, we have just 1 and 3. And for 4, we have two options. We have 1 and 4 and 2 and 2. What are we trying to get? Well, we're trying to subtract to get a negative 1. So I'm going to go ahead and, let's see, I'm going to test. I'll pick 1 and 3 from here, which once again I got from here. And then I'll go ahead and pick 1 and 4, which I got from there. And let's test these guys. I'm going to go ahead and multiply this way, so I get 4 and 3. Now, I can subtract these to get negative 1. If I have a positive 3 and a negative 4, I'll get the negative 1 I'm looking for. Okay, so we know that the 1 and 3 went together, and the 1 and 3 were the x values. This is going to be 3x, and once again, we set those up for the outside, so that'll be 1. And those gave me the positive, so I'll have the positive sign. Next, we had the 1 times the 4, and that will give me my inside value. So that'll be x times, and we knew that the 4 had to be negative 4. Okay, so we factored it. Once again, if you're still struggling a bit with factoring, please email me and I'll send you some resources for practicing the factoring. Definitely an important skill to have at this point in the course. Okay, so, it's factored. What do we do? Well, we know that the possibility is this can equal 0 or this can equal 0. So let's go ahead and set them up equal to 0. Okay, I'll just draw that little line down the middle, separate them, and let's go ahead and solve. Plus 4 to both sides, and I have 3x equals 4. And then dividing both sides by 3, I get x equals 4 over 3. Next side, minus 1 from both sides, and I get x equals negative 1. Alrighty, and those are my answers. The zero factor property. So if you see a quadratic, definitely a good idea to try solve with the zero factor property, which means you need to be able to factor well. So once again, if you need help with any of factoring, just send me an email and I'll send you some resources. Alright, exam 3. Now we're at word problems, so we're actually going to be using quadratics. And quadratics show up a lot in the real-world applications. For example, just think if you're standing on the ground, right? Let's say you're playing ball with somebody, right? You throw a ball in the air, what shape does it make? Well, usually it makes something like this, which we would usually call a parabola. That's the shape we describe it as, and the equation for this shape is a quadratic. Okay, so that shape, that little curve there, it's sort of a parabolic type shape. Sort of a simplistic way of describing it, but that's an example of where you'd see it in the real world. So the cool thing about equations with quadratics is a lot of the times we can do something like the problem we have here. So a small rocket is launched vertically upward from the ground. Let me draw a picture. So we have the ground, and we've got a little rocket, little fins, and we launch it in the air, and what happens? It goes up, and more than likely it comes down, right? What comes up comes down. Okay, so the function h of t equals negative 16t squared plus 128t can be used to find the rocket's height, h, in terms of the time t. Okay, so this equation is relating the height of the object to the time. All right, so we have h of t equals negative 16t squared plus 128t, where t is time and h is height. So now the question is, how long will it take the rocket to reach a height of 256 feet? So what am I trying to figure out? I'm trying to figure out how long, so that's time. We're solving for t when what? When we have a height of 256, when h equals 256. Okay, so that's what we're doing. So we're going to go ahead and, how do we figure this out? Well, remember, h of t is the height, and we are given the height of 256. So go ahead and plug that in, and we're solving for t. Okay, let's go ahead and, well, what kind of an equation is this? It's quadratic. We have that square. So I'm going to try to use the zero factor property. So let's go ahead and minus 256 from both sides. And then subtract the other side by 256. Okay, so now we have 0 equals negative 16t squared plus 128t minus 256. Okay, so first off, what do I think about when I'm looking at this? One, I don't like my t squared value being negative, so I want to get rid of that. And then I'm asking myself, these numbers are all kind of big. Is there any way I can simplify them? Well, I know they're all even numbers, so I could possibly divide them all by 2 and make them smaller, right? It's easier to work with smaller numbers. But I want to see if I can divide it by something bigger. So I'm going to see if I can divide 256 by 16. and then check if I can divide 128 by 16 as well. And if I can't divide by that, I'll slowly whittle down the numbers until I get to what I can divide them all. But I know they're all even, so I could divide them by 2. But why not go with a big fish while you can? Okay, so can 16 go into 256? Well, 16 can't go into 25, so I have to see if I can get to 256 quickly. Think. 16 is close to 20, right? And there are how many 20s in 100? There are 5 20s in 100, right? So 5 20s give me 100, which is close to 256. So let's do, once again, I'm really approximating here. This is just my brain work thinking. That's going to give me 200. But I want to be close to 256, so approximating 20 and 20. So I'm going to go ahead and guess with, let's say, 13. Okay, because about 12 20s got me close to 256, and 16 is a little smaller. So let's go with 13. 16 times 13, what would that give me? 18, 4, 6, 1. So 8, 2, 8. That's a little too small. Let's try something bigger. It's close. How about 15? That'll be 20. Oops, sorry, that'll be 30. And then 5 times 1 is 5. Plus 3, 80. 0, 6, 1. So it'll be 0. 8 and 6 is going to give me what? 14? 240. Ooh, that's really close. In fact, if I add 16 to this, I'll get 256. Okay, so I know that 16 times 16 would be 256. So let's go ahead and write that down. Let me just check that. So it's going to be, what is that? 16 times 16 is 36. 9, 0. 6 times 6 is 6. 6 times 1, or 1 times 1 is 1. So that'll be 6. 256. Ah, we're right. Okay, so I know that 256 is divisible by 16. I also know 16 is divisible by 16. So now we just have to check if 128 is divisible by 16. And if it is, awesome. We've made our equation way smaller, which is always the goal. Okay, so 128. I'm going to make a guess. 16 times. Well, I know it has to be smaller than 16, right? I forgot what it was when we had 13. Let's go ahead and try. Well, 16 times 10 would be 160, right? So we know it needs to be smaller than that. Let's try 16 times 8, maybe? That'll work. So 16 times 8. 6 times 8 is 48. 8 times 1 is 8. Plus 4 is going to be 128. Hey, what do you know? They're all divisible by glorious 16. Awesome. But once again, I wanted to get rid of that negative, so let's go divide everything by negative 16. Also have to divide that 0 by negative 16 as well. And then we get 0 equals t squared plus, it's a negative because we're dividing by that negative. 8t plus 16. Okay, so we managed to figure that all out. Now, the goal. Oh, look how beautifully small and simple all those answers are. I mean, all those terms. So much easier to factor this than trying to factor the one above. I mean, at least to me, it's easier to factor. So, we're looking for factors of 16 that would, when I add them together, I'll get a negative 8. And we just have t because we have a positive 1 in front of the t. Well, I know they should both be negatives because I want to add to get a negative. Oh, and then factors of 16, when I add them and I get 8, that's just 4 and 4. Awesome. Hey, those are the same exact thing. Well, so we know that using the zero factor property, t minus 4 equals 0, or t minus 4. Now at this point, just write both of them down. It shows me that you know how to do the zero factor property, even though they're the same thing. Slightly redundant, but just it shows me you know how to use the property. So we get x equals 4, x equals 4. So what is my answer? Well, the question was how long will it take for the rocket to reach a height of 256 feet? And your answer would be, it would take And don't say it would take the rocket. Okay, be specific. It would take the rocket what? For what? It should be in terms of seconds. I am sorry. Seconds. That should have been written down. It'd take 4 seconds for the rocket to reach a height of 256 feet. Okay, so as we noticed in this problem, that was a small typo of mine. If a unit does not show up, what would you write? Well, you can either email me during the exam and ask me, or you can just write units. Okay? That way I know you recalled there were supposed to be units and it was a typo on my end. But usually if it's a typo on an exam, I'll just give the points back because I did not provide the correct information. Okay, so last one. Example 4. The length of a room is 2 meters less than 3 times the width. The area of the room is 96 meters squared. Find the width of the room. Okay, so this is talking about a room, which I can visualize there, right? And it's talking about the length and the width. Going to assume it's this rectangular room. At this point in time, you can assume it's rectangular, unless you're told it's a triangle. And we have, what do we know? Well, the room is 2 meters less than 3 times the width. And we're asked to find the width. Okay, as usual, we need to create the variable unless we're given the variable. Notice before, we were given the variable, so we didn't have to create it or write a let statement for this problem. But for example 4, we're not given the variable, so we need to write a let statement. So I'm going to let W equal the width of the room. Once again, how do you know what the variable should be? Well, it's the item you're trying to find. It's the question, right? Find the width. Okay, so the length is 2 meters less than 3 times the width. So knowing that the length is supposed to be 2 meters less than 3 times the width, so that's going to be 3W minus 2. And then the width is, well, that's just going to be W. All right, so we've set up this part. Now we need to create the equation to solve. What information do I have that I haven't used? Well, I'm told the area is 96 meters. So I know that area is 96. Well, how do we find the area of a rectangle? The area is just length times width, right? So we know that the length times width must equal 96. And we have the length and we have the width. So let's go ahead and plug this in. So we know that 3W minus 2 times W should equal 96. Ooh, and what do you know? We have a quadratic equation. Now you might be tempted to go ahead and factor or set each of these to 0 at the moment, but we have to be careful. To use the zero factor property, we need one side equal to 0, which at the moment it's not. So let's go ahead and do that. Let's minus 96 from both sides. And at the same time, I'm going to go ahead and multiply in that W. So I get 3W squared minus 2W minus 96 equals 0. Okay, so we've done the 0 part. Now we need to factor. So starting off, let's go ahead and find the factors. Now it's going to be a little difficult because 96 is rather large. But we can't simplify any of these because 2 doesn't go into 3, and then 3 doesn't go into 2. So I can't simplify any further, which means I'm going to have to take some time with factoring 96. Okay, so factors of 3, well, that is easy. That's just 1 and 3. Now the factors of 96, that's going to be a little hard. But I'm going to be strategic, trying to find the factors of 96. I know that I want to subtract and get a negative 2, which means I'm not going to look for the big factors of 96, like 1 and 96. Instead, I'm going to look for the factors that are closer together. Well, I know that 96, if I divide that by 3, that will give me 32. What are factors of 32? Well, I know 32 is divisible by 2. let's see, 2 can do that 16 times. So once again, I'm just factoring out 96 to see if I can get close factors. And 16 is 4 times 4. So let's see, what could I create? 3 times 4 is 12. So I could do 12 and 8. Or another factor I can create from this is I could do 6 times 16. Okay, let's go ahead and see if one of these works. If not, we'll have to go back to the drawing board. So let's go ahead and set up our testing. From 3, the only ones we get are 1 and 3. So we're only going to be able to use that. So 1 and 3, I'm going to set up 2 different separate testing. Let's test with 12 and 8. And then we'll test with 6 and 16. So 12 and 8. Once again, remember, the plan is we're trying to find things we can subtract to get a negative 2. Okay, well, 3 times 12, that is going to be 36 and 8. Can I subtract those to get negative 2? No. Next one, let's try 3 and 8 is going to be 24, and 12 and 1 is going to be 12. Can't get negative 2. Okay, so that did not work. Okay, let's try the next one. And if that doesn't work, we'll have to go back and look for more factors of 96, which I don't want to do. Okay, so 6 times 3 is going to be 18. And 1 times 16 is going to be 16. Can I subtract those to get negative 2? I can! Negative 18 plus 16 would give me that negative 2. Okay, so let's go ahead and plug these in. Let's set this up correctly so we know, because we have that minus 96, that my signs are going to be positive and a negative sign. So we have 3W. Let's see, the 3 got multiplied to the 6, which means the 6 will be over here. And they had the negative, so that'll be negative 6. And then the 1 got multiplied to the 16. So that'll be 16, and we knew the 16 was positive, so it gets the positive sign. Once again, if you need any assistance with factoring, either stop by my office hour, email me about setting up an office hour, which I can do outside of my normal office hour times, or just email me about other resources I can send. Okay, so it is factored. Now what do we do? Well, we can set each factor to 0. And solve. Divide by 3, divide by 3. So W is going to equal, that should be negative 16 divided by 3. Or, add 6 to both sides, and we get x equals 6. Okay, so we have 2 options for our answer. Do both of them work? Does one of them work? How do we know? Well, this is where our critical thinking brain kicks in. Well, at least it should have been thinking a while ago, but let's think a little more critically. W is the width of the room. And I have a negative answer and a positive answer. Can I have a negative width of a room? No, I can't. So because of that, I'm going to cross out my answer and write extraneous. Okay, make sure to do that if you cross out your answer and write extraneous. So show me that you know it doesn't work. Which means 6 would be our answer. It doesn't make any of these not make sense. It makes sense for that to be 6, and then 3 times 6 is going to be 18 minus 2, which would be 16. So 16 and 6 make sense for the width of a room, so that works. So my answer would be the width of the room is 6 what? 6 meters. Period. All right, and that is my answer. Once again, if you have any questions, please stop by an office hour or send me an email.